Hello. So this is the questions and answers on electrolysis. Did you try the questions? Were you able to do all of the questions? I hope that you were able to do at least some of them. So let us take a look at the answers to these questions. The first question that you had was electricity was passed through a solution of concentrated hydrochloric acid as shown below. Now, the first thing that you think about when you have any question on electrolysis, the first thing you ask yourself, what is he doing? Electrolysis of concentrated hydrochloric acid. So you think, what will happen at the anode, what will happen at the cathode, which ions do we have, and so on. Of course, if I have hydrochloric acid, that means I have H plus and Cl minus, and this is concentrated. And that means at one end I'm going to have hydrogen gas, and at the other end I'm going to have chlorine gas. So he tells you that bubbles were observed at both electrodes. That's because you have hydrogen on one electrode and chlorine on the other. But then he's asking, give one other expected observation. Now, when you look at the diagram, you see that there is a light bulb. Can you see the symbol for light bulb? That's the circle with an X in it. That's the symbol for the light bulb. Now, when we're doing electrolysis, of course, electricity is passing through. So one expected observation would be the bulb lights up. The next question says, label the electrodes. Where are the electrodes? The electrodes are those square things inside the test tubes. That's the electrode. So you need to label them. That means you need to tell me which one is the anode and which one is the cathode. Now, how do I know? The one that is attached to the positive end of the battery is the anode. The one that is attached to the negative end of the battery is the cathode. How do you know which one is the positive end and the negative end of the battery? If you look at the diagram, the symbol for the battery, it has two lines. The line that is longer, you should know this from physics, the line that is longer is the positive end of the battery, the shorter line is the negative end of the battery. So the electrode that is attached to the positive end of the battery is the anode. The electrode attached to the negative end of the battery is the cathode. Name the gas given off at the cathode, and you know that the cathode is the negative electrode, and we said which one will go to the negative electrode, the H plus or the Cl minus. The negative electrode will have the positive ion going to it, so that is the H plus, so the gas given up there is hydrogen. So just why at the beginning of the electrolysis, no gas was collected at the anode. Which gas do we expect at the positive? We expect chlorine. Now, at the beginning, I don't see any bubbles, and then I start to see bubbles. You should know that chlorine is a gas that dissolves in water. So when it starts to give a few bubbles, the bubbles will dissolve in water, and then when it gives a lot of bubbles, the bubbles will start to show. So this is because chlorine dissolves in water. Okay, the diagram below shows an electrolysis cell used to manufacture sodium from molten sodium chloride. Which letter in the diagram represents the anode? You should know that the anode is the positive electrode. Which one is the positive electrode? That is E, right? Which one is the electrolyte? We said the electrolyte is the liquid that is in there, in which the electrodes are placed. So which one is the liquid? That is A. State the name of the product formed at the positive. Well, I need to go back. What is he doing? He's doing electrolysis of molten sodium chloride. So the positive, which one? That means I have sodium ions and chloride ions. Which one goes to the positive? The one that is actually negative ion. So I have chlorine going to the positive, and the sodium will go to the negative because this is molten. There is nothing else except sodium ions and chloride ions. Which one of the following substances is most likely to be used for the anode? We said the anode usually is made of what? It's usually made of graphite. This is the cheapest, and it is the nonmetal that conducts electricity. Calcium is manufactured by the electrolysis of molten calcium chloride, and he's doing electrolysis of molten calcium chloride. What are the products at the anode and what are the products at the cathode? calcium chloride. That means calcium is positive, chloride is negative. Which one goes to the anode? The anode is the positive electrode, so the negative ion goes there. Now, the negative ion is chloride, but when it goes to the anode, it gives up electrons and becomes chlorine. Do you notice that? So my product is chlorine, not chloride. Which one is formed at the cathode? Well, the calcium ions are the positive. They go to the negative electrode and they form calcium atoms or calcium metal. So just a non-metal that can be used as anode. We said the anode is made of carbon. Now he's saying a non-metal. In the other question he was saying a substance. So we said graphite. But when he says a non-metal, non-metal is the carbon, because the graphite is made of carbon. So just the product formed at each electrode when molten copper 2 chloride is electrolyzed. Again, I'm going to do electrolysis of what? Copper chloride. So the copper is the positive ion, the chloride is the negative ion. Remember we said, if you don't remember, it's the first one that's usually positive and the second one that is negative. So the chloride positive ion will go to the negative electrode. What did I say? Copper. Copper is the positive ion, it goes to the negative electrode, and the chloride is the negative ion, it goes to the positive electrode. So chloride is negative, it goes to the positive, but it forms what? It forms chlorine. Now the copper positive ion goes to the negative electrode, it forms copper metal. Molten magnesium bromide is electrolyzed. Predict the products at the anode and the cathode. Again, I have molten, so I have only these ions, magnesium and bromide. The magnesium is positive and is negative. So which one goes to the anode? The anode is the positive, so the negative ions will go to it. Bromide ions will go to the positive electrode and form bromine. Now, which one goes to the negative electrode? The magnesium, which is positive ion, will go and form magnesium metal. Do you understand the idea? The positive ion goes to the negative. The negative ion goes to the positive electrode. Okay, sodium chloride is also a salt. Solid sodium chloride does not conduct electricity. So just two things you could do to make solid sodium chloride conduct electricity. Remember that we said sodium chloride is ionic. But we know that ionic substances do not conduct electricity unless if they are what? Molten or in solution. So if I have solid sodium chloride and I wanted to conduct electricity, I would either dissolve it in water to make an aqueous solution or heat it so that it becomes molten. Okay? Molten zinc chloride was electrolyzed using the apparatus shown below. Choose a word from the list below which describes the positive electrode. Remember that we said the positive electrode is called what? It's called anode. The anion is the ion. The anode is the electrode. State the name of the product formed during this electrolysis at the negative electrode. Again, what is he doing? He's doing electrolysis of molten zinc chloride. That means the zinc is the positive and the chloride is the negative. So which one goes to the negative? It is the zinc. Which one goes to the positive? It is the chloride to form chlorine. Again, please note which one is he asking about. So here he's asking them in the reverse order. In the other question, he was asking the positive first. So read the question. Read the question properly. Okay? So just the name of a non-metal which can be used for the electrode. Again, the non-metal is carbon. Okay, molten potassium chloride is electrolyzed. Two products are formed. Complete the table below to show the name of the electrodes and the products formed. So first of all, we want to name the electrodes. If the electrode is positive, it is called what? The positive electrode is called the anode and the negative electrode is called the cathode. Now, which products are formed? Well, what is he doing? He's doing electrolysis of molten potassium chloride. Now, potassium is the positive, chloride is the negative, and we said the positive goes to the negative electrode, the negative goes to the positive electrode. So which one goes to the positive? It is the chloride ion to form chlorine, and the potassium goes to the negative to form potassium metal. Okay, the apparatus shown below is used to electrolyze concentrated aqueous sodium chloride. So he's doing what? Concentrated aqueous sodium chloride. So just a suitable substance which could be used for the electrodes. Again, here he's saying substance, so I can say graphite. Now, state the name of the gas given off at electrode A and electrode B. So I take a look. Which one is A? A is the positive. Okay, what do I have? I have concentrated sodium chloride. That means my negative ions are either chloride ions and actually both hydroxide ion, because I have water. This is an aqueous solution. So which one will react? Well, we said if I have a choice between chloride and hydroxide, this is a concentrated solution. That means chloride is in higher concentration. That means it is the chlorine that will be formed. If it were a dilute solution, it would be the hydroxide that will react to form oxygen gas. Okay, at electrode B, the negative, here we have again two choices. I either have the sodium ion, which is a positive ion, or the H plus ion from the water, because I have an aqueous solution. And we said if I have a choice between Na plus and H plus, it is the H plus that will react. So that will give me hydrogen. Okay, please study all of this very well because it's very important. Okay. This is another similar question. He says, state the name given to electrode A. Again, A is the positive, so the positive is called anode. Explain why aqueous sodium chloride conducts electricity, but the solid does not. Again, we said sodium chloride is an ionic compound, so the aqueous solution has free moving ions, while the ions are not free to move when it's a solid, because as a solid, it's a rigid crystal lattice that it does not allow the ions to move. Concentrated hydrochloric acid can be electrolyzed using the apparatus shown. What is meant by electrolysis? What do you understand by the term electrolysis? We said electrolysis is what? It's the breakdown of a compound using electric current, or we said it's the breakdown of an ionic compound using electricity. Either one is correct. What is the name given to the positive electrode? Again, the positive electrode is the anode. State the name of the gas given off at the negative. Well, let's go back. What was he doing? He was doing concentrated hydrochloric acid. So concentrated hydrochloric acid, and he wants at the negative. At the negative, I have, actually I don't have a choice. I just have H plus ions. Okay, so H plus ions, so that will give me hydrogen. Complete the following sentence about electrolysis using words from the list. Electrodes made of graphite, or what was the other alternative? I want an inert electrode. So it's either graphite or platinum are generally used in electrolysis because they are inert. And we said, remember, inert means that they don't react with whatever I'm doing electrolysis of. A chemist electrolyzes a sample of molten copper chloride. Name the products formed at the electrodes. Again, copper chloride, that means copper ions and chloride ions. And this is molten, so there's nothing else. So at the anode, which is positive, the chloride reacts to form chlorine. At the cathode, which is the negative, the copper ions react to form copper. Write an equation to show the formation of the product at the negative. Which one is the negative? The negative is the cathode. So I'm trying to say the copper 2 plus ions. How did I know it was 2 plus? He has the formula up there, CuCl2. So that means that the valency of copper is what? 2. So that means it has 2 positives. And that means it will need 2 negatives to form copper. The apparatus shown can be used to electrolyze aqueous sodium chloride in the laboratory. Identify gas A. Again, I go back. What is he doing? He's doing aqueous sodium chloride. Now, gas A is at the positive or the negative? Gas A is the one at the electrode connected to the negative. So I want the positive ions. Now, which positive ions do I have? I have sodium and I have H plus from the water. So which one reacts? Again, choice between sodium and H plus. H plus will react to form hydrogen. Some of the solution formed after the electrolysis was tested with the indicator phenolphthalein. The indicator turns pink. Explain this result. Again, if I have sodium chloride, it will form hydrogen at the negative. What does it form at the positive? If he does not tell you whether it's concentrated or not, you assume that it is concentrated. Did you hear that? If he does not mention if it is concentrated or dilute, you are assuming that it is concentrated. So which one is formed? It's the chlorine that is formed. So chloride ions react to form chlorine. H plus ions react to form hydrogen. And what is left in solution? I'm left with the sodium ions from sodium chloride, and I'm left with the hydroxide ions from the water. So actually, I have in my solution sodium hydroxide. So if I put phenolphthalein, the indicator turns pink. This is because sodium hydroxide is formed, and that is an alkaline solution. Do you remember all of this? Please, if you still do not understand, go back and study the chapter. And if you still have any questions, please do not hesitate to send me an email or even call me by phone, and we will discuss it. The diagram shows how sodium chloride solution can be electrolyzed and the products of electrolysis collected. So here he's doing electrolysis of sodium chloride solution. Draw an arrow on the diagram, show the direction of electron flow at point X. Okay, so point X is the wire that is connected to which end of the battery? It's connected to the negative end of the battery. And that means that the electrons in the wire will be repelled away from the negative end of the battery. So my arrow should look like that. Can you see the arrow at X? It should be going away from the negative end of the battery, and that means it goes towards the electrode, and that's why the electrode is negatively charged. The diagram shows one of the gases being collected in test tube Q. Identify this gas. Where is test tube Q? Test tube Q is the one that is at the negative electrode. So what is formed at the negative? Well, I go back and say, what is he doing electrolysis of? He's doing electrolysis of sodium chloride solution. So the one that goes to the negative are the positive ions. Which positive ions do I have? I have sodium and I have the H plus from the water. And we said, if we're choosing between sodium and H plus, which one reacts? The H plus reacts, so my gas is hydrogen. When the concentration of sodium chloride solution is low, the gas collected in test tube P is mostly oxygen. That is because when the concentration of sodium chloride is low, that means I'm doing a dilute solution of sodium chloride. We said in that case, it is not the chloride that will react, it is the hydroxide that reacts. So the hydroxide reacts to give oxygen gas. What is the equation? He wrote the equation, and all he's asking you to do is to balance it. So let's try and balance this. We said when we balance, how many hydrogens before the arrow? 1. How many hydrogens after the arrow? 2. So I need to put a 2 in front of the OH minus. But then that means I have 2 oxygens, and on the other end I have 3 oxygens. So I have to increase that to 3. But that means that that increases the hydrogen, and so on. And you keep going until you find that you have to put 4 in front of the OH minus. That means you need 4 electrons and you need 2 water in order to balance the hydrogens. Do we understand this? Okay. Sodium is manufactured by the electrolysis of molten sodium chloride. Sodium is produced at the negative and chlorine is at the positive, of course. Why does the sodium chloride have to be molten? Again, why does the ionic compound have to be molten? To have free moving ions in order to conduct electricity. The ionic half equation for the formation of sodium is this, right? The ionic half equation for the formation of chlorine from chloride. So you're starting with chloride. What does the chloride do? It loses electrons to form chlorine. Chlorine is diatomic, so I have to write it Cl2, and that means I need to balance in that way. Do we understand all of this? Okay. This apparatus is used to electrolyze a concentrated solution of sodium chloride. The ionic half equations for the reactions at the electrodes are these. So he's saying the negative, this is what happens. Positive, this is what happens. Don't be shocked by the unusual way of writing the equation. Just ignore that. And let's see what he's asking about. The ionic half equations for the reactions at the electrodes are this. State how these ionic half equations show that equal volumes of the two gases should be collected. Okay, when you are comparing the volume of gases from the equations, first of all, you need to have the same number of electrons. So he's saying from this equation that the water will take 2 electrons to form hydrogen, and the chloride will give 2 electrons also. So in that case, I want to compare how many moles of hydrogen are formed and how many moles of chlorine are formed. I find that they are equal. So that means that the amount of gases that should be formed are equal in volume, and this is because for the same number of electrons, I get the same number of moles of the gas. So just why the volume of chlorine collected is less than expected. Again, we said chlorine is less than expected because chlorine dissolves in solution. Okay. A student investigates electrolysis using this apparatus. So he gives you apparatus separately, and he's saying the student electrolyzes potassium chloride, collects samples of any gases formed, complete the following diagram to show how to assemble the apparatus. So you've seen the diagrams in the previous questions. How do we assemble all of this to do electrolysis? He gives you the basic container. You need to put the electrodes into the test tubes attached to the positive and negative end of the battery, and you need to fill that with the solution. So this is the diagram that you're supposed to have. The table shows the half equation for the reaction at one electrode. So this is the one where we take electrons. If we take electrons, that means we are at the negative electrode. Remember that gain of electrons happens at the negative, because you go to the negative to take electrons, and then you go to the positive to give it electrons. So the other one would be the positive electrode. Now what happens at the positive electrode? Well, I go back and see. This is something that has chloride, so the chloride will lose electrons and form chlorine gas. The next question says the diagram shows apparatus that can be used to electrolyze what? Dilute sulfuric acid. First of all, label the electrodes by writing the symbols positive and negative. Well, how do I know that? Well, he says that at one of the electrodes, he collects the hydrogen. So the hydrogen is usually a positive ion. This is formed from H+. The H+ will go to which electrode? It will go to the negative. Then the other one must be the positive. Can you see the signs that I put in the small circles? Hydrogen is formed from H+ ion, so that must be the negative, because the H+ goes to the negative, then the other one is the positive. The equations for the reactions occurring at the electrodes are this. The volume of hydrogen gas collected after a few minutes is shown on the diagram. Draw another line on the diagram, show the volume of oxygen gas collected after the same length of time, and explain your choice. Okay, again, I want to put a line in the test tube to show how much oxygen I will collect. How do I know how much oxygen I will collect? Well, I look at the equations. The first equation says the H+ takes 2 electrons to form H2. The other equation says the 4OH- will give 4 electrons. Now, first thing, in order to compare between the number of moles of hydrogen and oxygen that will be formed, the number of electrons have to be the same. In the other equation, they were already the same, so we didn't do anything. But here, they're not the same. One of them takes 2 electrons, the other gives 4 electrons. Now, what do I do in order to make them the same number of electrons? I can multiply everything in equation 1 by 2. So, instead of having, what did I have? I have 2H+, 2 electrons, 1 H2. I multiply through by 2. So I get 4H plus, 4 electrons, and 2 hydrogens. So in this case now, the first equation has 4 electrons, the second equation has 4 electrons. So now I can compare the number of moles of hydrogen and oxygen. In this case, I have 2 moles of hydrogen for 1 mole of oxygen, and that means that the amount of hydrogen gas that I should get should be twice the amount of oxygen gas that I get. So that means that if he has that line for hydrogen, the line that I draw for oxygen, can you see the line I drew in the test tube? It should show me that I'm going to collect half the amount of gas collected in the other test tube, and that would be my oxygen gas. Did we pay attention to that? Okay, now, so the explanation is when the number of electrons are the same, so if they're not the same, we multiply through to make them the same. The number of moles of hydrogen is twice that of oxygen, so the volume of hydrogen should be twice. The diagram shows the diaphragm cell used in the electrolysis of concentrated sodium chloride solution. So what is he doing? Concentrated sodium chloride. Identify gas A, gas B, and solution C. Where is gas A? I take a look. Is it positive or negative electrode? The gas A is collected at the positive electrode. So this is the negative ion. What negative ions do we have? We have chloride and hydroxide, because this is a solution. Concentrated means I have a lot of the chloride, and that is the one that will form chlorine. Gas B is at the negative. Okay, what goes to the negative? The positive ions. Which positive ions do we have? Na plus and H plus from the water. And we said when we compare between them, it is the H plus that reacts to give hydrogen gas. Now, what is left in solution? If I started with sodium chloride solution, Na plus, Cl minus, H plus, OH minus, the chloride has reacted and the H plus has reacted. So what is left in solution is the Na plus and the OH minus, and that forms sodium hydroxide. This apparatus is used to electrolyze the ionic compound lead bromide. Lead bromide is insoluble in water. When the apparatus set up as shown, electrolysis does not occur. State what must be done for electrolysis to occur. I look at the setup. What's wrong with the setup? He put solid lead to bromide in the container, and we said solid will not conduct electricity. So what do I need to do? We said I need to heat it in order to become molten. I want to melt it so that now I have molten lead bromide. Then you can do electrolysis of the molten compound. When the necessary change is made and electrolysis occurs, particles A, B, and C move in the directions shown by the arrow. Identify each of particles A. Can you see the arrow up in that diagram where it says A? That is the arrow going through the wire. Which particles go through the wire? We said the wire is made of metal, so what is going through it are electrons. Okay, now B and C, can you see where the arrows for B and C are? Okay, B and C are inside the molten lead bromide now that it is molten. So what are B and C? B and C are the positive and the negative ions, right? B is going towards the cathode. The cathode is which one? The cathode is the negative. So B is something going to the negative, so it must be the positive ion. Which one is the positive ion that we have? Lead ions. And remember that this is lead 2, that means it is lead 2 plus, our Pb 2 plus. C is the ion going to the anode. The anode is the positive, so C must be the negative. Which negative ion do we have? Br minus. Okay? The next question says, I have this, and that's the same diagram. Write an ionic half equation for the reaction at the cathode. Where is the cathode? The cathode is the negative. So the one that goes to the negative is the positive ion. So it is the lead 2 plus. Since it is 2 plus, it needs 2 electrons and becomes lead. State why the reaction at the cathode is described as reduction. Do you remember from previous chapters what was a reduction? Reduction was gain of electrons. So this involves gain of electrons, and that's why we call it reduction. Okay, that is the end of these questions. If you were not able to answer all of them properly, please go back, study the notes in your PDF version, go through the video again if you need to, the video for explanation of the chapter, and if you cannot understand at all after all of this, please send me an email. Okay, and then study hard so that we can do a quiz, and let me know when you are ready for the quiz.